When you're ready to use your Battlab-One to understand the firmware impact on your current profile, the first step you're going to need to do is find a spare pin on your microprocessor. In my case, I'm using my garage door sensor, which uses an ESP12S. You can see I've bodged in a wire on GPIO4, and I'll use this to trigger on in my firmware. So here I've opened the firmware for my ESP8266, and the first thing I do in this firmware is set up a few pins. These are some sensor pins that I turn on and off to read data off of a temperature sensor, and I have a status sensor. And then the third pin I set here, this is the trigger pin that I set up on the ESP8266. So I set it low first because we trigger on a low to high event. And you'll see in this code, I've just got a basic function called read sensors. And then I've got another function called go to sleep for, I think it's about 10 seconds. So basically what the function does is it first triggers my Battlab-One trigger input by setting that pin to high. And then it does its read. It reads a status sensor. It goes through and first sets a pin high, which turns on a MOSFET actually, to read a temperature sensor. And you'll see that this temperature read is actually happening 1,000 times. Why I would do it 1,000 times and then average it for 1,000, I'm not sure, but it's just for demonstration purposes. And we'll compare this 1,000 iteration for loop to running it, say, 3 times, just to give an example of how we might look at the impact of firmware on our battery life. So I run it 1,000 times. Once it goes through and reads all that data, it does some printouts, and then it turns my trigger sensor or my trigger input low to turn off the data capture. And then it goes to sleep for, I believe it is, again, about 10 seconds. These are microseconds. So we'll go ahead and run this, and we'll take a look at what the output looks like on the Battlab-One. So now I'm back in the Battlab-One software. You can see I've selected the lithium-ion battery for the ESP8266. It's driving for 0.2 volts. And I've turned on the trigger PSU on capture, and I've turned on the power supply unit. And now what I'm going to do to trigger the capture mode is click this external trigger button, and you'll see that the capture button will turn to, say, ARM trigger. Once I click on that, it will begin the process of capturing the data for the device under test. And you'll see we captured that bit of firmware where we went from a low to high and then a high to low event on that pin 2. And the average current was about 68.63 milliamps. You can see we captured about 400 milliseconds worth of data. And now I know I've got 10 seconds worth of sleep current. I'm going to go ahead and just capture that real quickly and see what the overall life expectancy is for this particular environment where we've got 1,000 iterations on that ADC read. And then we'll compare that to the 3 iterations on the ADC read to see what the effect of that firmware was. So right now we've got about, let's call it 39 days worth of expected battery life based on this particular firmware profile. So here we have the same firmware again. The only difference this time is that we're going to set the number of iterations for reading our ADC for the temperature read to 3 instead of 1,000. And we'll go ahead and run this on the Battlab-One and take a look at what this particular firmware change will have on battery life for this particular example. Okay, now we'll run a second iteration through the Battlab-One using the new firmware. Again, I'm using a lithium-ion battery, driving it at 4.2 volts. I'm going to go ahead and turn on the trigger, external trigger, and I'll arm it. And we'll go ahead and capture the new firmware profile using the 3 ADC reads versus the 1,000 ADC reads. And you can see now that we've captured almost 15 milliseconds worth of data, it looks like. Yeah, just about 15 milliseconds using the 3 ADC read versus the 1000 ADC read. And same average current, roughly 68.65 milliamps. And I'll go ahead and capture the sleep current at this point, and we'll compare what the two profiles look like from an output standpoint. And in this case, the sleep current is going to come in roughly the same, should be roughly the same average as the previous one. And now you can see we've gone from about 39 days to almost 475 days worth of estimated battery life. So our expected battery life has gone up quite significantly just by changing that one little firmware component from 1,000 reads to 3, which is pretty significant. And we can go back and test, and we could have saved the profile so we can compare them. I'll do that in maybe a separate video to show how to save results. But if we go back and say, let's just enter in that 400 milliseconds, I think it was 390 milliseconds estimate, and we'll run optimize, and you'll see that here's our original roughly 39 days using that 1,000 iteration bit of firmware versus using 3 iterations. So pretty significant difference from just a minor firmware change in your software.